think they would be pretty good. Yeah. But in my opinion, there's a lot of things that we teach you guys that you may need to use one day, but you also may not need to use it. Percentages, I feel like every student that graduates from Elkin High School should have a decent understanding of percentages. So, let's do some review on percentages, and if we don't get it finished, we'll finish it on Monday. So, a percent is a ratio compared to 100. Per, right, means like for every 100. Cent is a lot of times it's a prefix to a word. What words do you know that have something to do with cent that involve 100? Money, right? Money, for a cent, you got 100 cents equals $1, right? You got century, which is 100 years. I'm not sure about centaurs. I'm not sure if that's related or not. I'm not up on those, but there's a lot of other places that you may see this. That means 100. So it's your amount per 100. So when you hear something like 23% of students play sports, that means if you had 100 students, 23 of them would play sports, right? It sort of standardizes everything for if there were 100, right? So, decimals decimals, percents, and fractions are all related. So, to change a decimal to a percent, you multiply by 100, okay? But multiplying by 100 just moves the decimal 2 places to the right. So if I have 0.23, that would be 23%. If I want to change 0.07 to a percent, I would just move that decimal 2 places to the right, and you got 7%. All right, percent. Let's write this. Percents should be bigger than their corresponding decimal. Okay. And if you guys will shut your computers, we won't need those anymore. It might be. I may have borrowed that one for the pre-quiz there. All right, so to change a let's see. So right here, I want you to change all 8 of those decimals to percents. It's the same rule for every one. Okay. Let's see. Riley, what'd you get for number 1? Perfect. Aiden, what about number 2? Very good. Where'd that 0 come from? Okay. You gotta move that decimal 2 places. What happens if you don't have any numbers once you move it 2 places? What do you do with it? You add a 0 right there, so that's where that 0 comes from on that one. Okay, Camel, what about number 3? Perfect, 123. Rosalind, what about number 4? Very good. Some students want to do 17% on that because they like just automatically move it to the end. But it's only 2 places. So just 2 places, 1.7. Okay? All right, Evan, 5. 300. That one doesn't even have a decimal, so what do I do with that one? Okay, I just add it, I put that decimal at the end because 3.0 is the same as 3, right? And I just move that decimal 2 places, add those zeros on the end. Very good. Okay. Let's see, Anna Grace, what about number 6? 80%. Caitlin, 7. 10.7. Very good. And Blakeland, what about the last one? 340%. Very good. Okay. All right. These calculators do not have a percent symbol. You have to know how to do this. When you're doing something in the calculator, you need to we need to be using decimals. So when we get an answer, sometimes we need to change it back to a percent for that. Okay. Desmos will accept a percent symbol, but I often find that that actually is more confusing to students than not having it. So if you just understand the moving decimals, it works the best. All right, to change a percent to a decimal, so we're going for a percent to a decimal, we need to divide by 100. 2 times to the left. So like for number 9, I don't have a decimal, so it's at the end. I need to move this 2 times to the left. I'd fill in a 0 right there, so I'd get 0.07. Okay, if you want to put the 0 here out front, you can. You can include it or not. It's okay. So you're just moving that decimal back 2 places to the left. You should get a decimal. It should be smaller than the percent that you started with there. So everybody try these real quick. I've heard that before. I've heard it. Yeah. Okay. All right. For 10, Ian, what will we get? Perfect. Okay. Isabella, what do we get for 11? 0.003. Good. That one throws students sometimes get that one wrong there when you have nothing in front of it. There, they miss a 0 a lot of times. Anna Grace, what about number 12? Very good. Lexi, what about number 13? Okay. So 0.20, or is it okay to write this way? Just 0.2? Yeah, that zeros on the end of a decimal are unnecessary, right? So if you want to include it, it's fine, but you don't have to for that. So either one of these would be okay. All right. Anya, what about number 14? Very good. And same thing here. 2.5 is fine. If you want to do 2.50, you can, but that 0 on the end is unnecessary, so you don't have to do that for that. Let's see. Lanaya, what about number 15? 0.00. Hold on. Need another 0, Donna. Yeah. 1, 2. Yeah, we're going to have 3 zeros. there. Yeah. 0, 0, 0, 5. Yeah. Sometimes, especially on one like that, I do actually like draw my two little places, put in my 0 right there, because sometimes it's hard to see. All right, Isabella? Okay. Do I have to have the 0 on the end? I do not have to have the 0. I could just call it 0.8. You don't have to put the 0 in front of it. I like the 0 in front of it just because it's kind of more obvious that the decimal point's there. Like if I write 0.05 and my decimal's real small, sometimes it looks like I just wrote 05. But you don't have to have it there for that. All right, questions? Okay, so finding percentages is not that difficult, but you just have to know what to do with it. So, in general, if you want to find a percent of something, you want to multiply that percentage as a decimal by whatever it is you're looking for. Okay, so for example, if I want to find 40% of 267, right, then I'm going to do 0.40 or 4, just 0.4, doesn't matter, times 267. And everything we do, really everything we do for the rest of this unit is going to be calculator active because exponentials are going to need a lot of calculators. So 0.4 times 267, 106.8. Yes. Did you say is over of equals percent over 100?
I don't remember. Maybe that's what it is. We divide the number by 10 and multiply it by, in this case, 4.
I mean, it will work here, but I would prefer for you to use the calculator on this stuff.
I usually do.
And I would prefer for you to use this method where you are multiplying by that percent, because especially we're going over these percentages, number one, because you need to know them for life. Number two, because we're getting ready to do exponential growth where things will be growing by a percent, so there's like a certain way I want us to do things that will lead into being able to do that well. There, and for this you'll need to multiply. There, okay. So, about 60% of the students at Elkin High School play at least one sport. I have no idea if that's true or not, but there are probably about 375 students in the school. How many play a sport? So this is something I always want to know, like whenever you hear like, so this percent of people in a survey said this. I really want to know how many people were in the survey, because that makes a difference. Like if you only surveyed 10 people, and that means 6 people said this, that's not very good, you know. Oh, statistics drive me nuts when I see them in the news. Because it can be like, oh, flu deaths in children under 2 are up by 120%. And that really does not mean a whole lot, because it could mean, or if it, let's say they're just up by 100%, it could mean that there were 2 kids and now it's 4, which, I mean, of course, every person is valuable, and that's a big thing for those people, but like statistically, data-wise speaking, we're not talking about much difference there, right? But it could also mean you went from 1,000 to 2,000, and that would be a much bigger deal, right? So a lot of times you can twist statistics to make them say what you want them to say, even if they don't really support it. So I often question things. To give you a wonderful example, I need to go back and find, I went to a workshop, and there was a study that was done And the title, like this study that they had done, compared people who did not drink at all to people who were heavy drinkers. Not moderate drinkers, not like drank once every now and then, but heavy drinkers. And in this study, these people that did not drink at all versus the people who were heavy drinkers, they found that people who did not drink at all were more likely to die at an early age than heavy drinkers. No. These are heavy drinkers. This is not. No. This is what happened. Okay, let me tell you what happened. So this guy that was presenting this was a math teacher. He said he read that and he's like, how is this possible? Because, often there's studies that might show benefits for like small amounts of alcohol. Although there's also studies that say that no amount of alcohol is worth the risk. So, that's kind of debatable. But in general, society generally says that heavy drinking is not good for your health. And there have been lots of studies to show that. That is true. But this was not just looking at people in car crashes. This was like death overall. But you are right. A lot of times drunk drivers don't die because they're, because the alcohol is slowing their system down so much that they don't react and they're not hurt as bad as the people who were not. But anyway, in this particular instance, this math teacher that was presenting about this, he said that he read that headline because this was in, I can't remember which, it was like in New York Times or something. This was not just like something that you find on like some website, on some that's full of fake news sort of thing. This was like in an actual well-established, publicized, New York Times sort of-ish thing. And so he read that and he's like, this cannot be true. How is this possible? And he read the whole thing and it had the statistics and everything. So he went digging some more about this. And the first thing he said to do, and this is important, is he said that anytime there's a study that claims something, what you need to ask is who paid for the study. So he looked into that. And do you know who paid for this study? Anheuser-Busch paid for this study. Do they have an Anheuser-Busch that makes beer? Budweiser is Anheuser-Busch. So, do you think they might have an angle here where they want you to think that you should drink? Because then they can sell you their beer. Yes. So, Anheuser-Busch paid for the study. So, that was a major red flag. So, he looked into it more. And whenever he got more information about the setup of the study was only looking at recovering alcoholics. So these were people who had been alcoholics. Everyone in the study was a recovering alcoholic. So some of the alcoholics did not drink at all, and some of the recovering alcoholics relapsed and started drinking again. And in this study, there was a slightly elevated number of people who did not drink that died, although it was not a large number of people that they were looking at. But you have to also consider that people who are recovering alcoholics have a lot of troubles in their life that, could have caused something to happen there. So, should we take this information and tell the general public that you are better off being a heavy drinker than not drinking at all? No. And in fact, this math teacher looked into that. He wrote a letter to the newspaper that had published it, and they eventually published a retraction of it, an apology for running the article about it. Because although it was true that in this study, heavy drinkers were less likely to die in this study than the people who did not drink at all, it was very misleading because, we weren't talking about just anybody out there. They didn't use thousands and thousands of people that from all walks of life, in that case. And most studies that have done that do not find that heavy drink. I'm not aware of anything that says heavy drinking is good for your health. Yep. That seems right. Because it definitely messes with your brain. You're not yourself. Yeah. Yes. So anyway, statistics can say lots of different things. So whenever you read something, I'm not saying you gotta you should think about what does this mean and how was this set up? How did they get these results? Because sometimes people have an angle on things. They are constantly telling you that coffee is either the answer to all of your health problems or is going to cause you to have some sort of terrible disease. Coffee seems to be one they study all the time and have varying conclusions on. Is it good for you? Is it bad for you? Who even knows? I love coffee. I need to do it. All right, so always think about that whenever you're looking at different statistics that you see. But this statistic that I completely made up for these notes, 60% of students are going to play at least one sport. So I want to know out of these 375, how many play a sport? So what do I do? Okay, and that should be a little more than half, right? So this would seem to be a little more than half, so that seems like a reasonable answer. Also ask yourself that for these problems, because as we get further. Okay. All right. A sweater costs $60. It is on sale for 35% off. How much does it cost after the discount? Okay. Try this on your own. I want to see what you get, and I want to see how you do it. I'm really interested in how you do it. I'll say what? We're not talking about that because we're doing this problem. I need to know how much this sweater costs. Okay. All right. How much does a sweater cost? Nope. $39. Okay. All right. So, how'd you get 21? Okay. That gives you $21. That's how much they take off. So then what do you have to do? 60 minus 21, which is 39. Right? So, important to know. Also, everybody who got 39, is this the way that you did it? Or did anybody do it differently? What'd you do? Okay, it can be done that way, but my way is the easiest. And my way is not this way. I've got a different way. Anybody? All right, anybody else do it differently? Let's see if anybody did. Okay, and this is the way we need to start thinking in order for us to be able to do exponential equations, okay? So, if a sweater is 35% off, what percent, I'm going to use this, that doesn't really make sense. What percent on is it? What percent of the price do you have to pay? 65. right? So if I do 100 minus 35, which is usually something you can do in your head because you don't usually go to a store and it's like 27% off, right? It's usually easy to subtract things. That gives you 65. So if it's 35% off, you have to pay 65% of the price. So if you take 60 and multiply it by 0.65, you will get 39 right away. And you don't have to do any subtraction. Just one step. So like if you're in a store and you see that this sweater was, $85 and it's 75% off and you want to know what the price is, you can just type into your calculator on your phone, 85 times 0.25. And you get the answer right there. You don't have to do like any complicated thing there. Or what if a sweater is $85 and is
30%, 35% of $60.
well, but then you still have to subtract.
I'm just typing the whole.
Yeah.
65%.
Yeah, I mean, you could just like type in the whole problem. But if you understand it, you can just type it in really quickly, right? You want to make sure that you actually do. Let's see. Okay, so this is how most insurance works. So whenever you have health insurance and you have something done, then there is what you call a deductible. Have you guys heard these terms before? Do you know anything about insurance? Usually I do not have. Yeah. Yeah. So you have a deductible, and then after that, your insurance pays co-insurance. So this is how it works. Until you meet your deductible, you have to pay the whole thing, right? So if your deductible is $1,000, you're going to have to pay the first $1,000 of your medical bill out of pocket. Yeah. So if your deductible is $1,000, you got to pay for that first $1,000. So Bob here, who has had knee surgery, his knee surgery was $14,000. So he had to pay $1,000 of that, right? So he paid $1,000 of his own money. Okay? But then how much does that leave that's left? $13,000. So the $13,000 insurance starts to kick in at that point. And most insurances are going to be 70-30 or 80-20. And that would mean that the insurance pays 70%, you have to pay 30. Or if it's 80-20 is another really common one, you pay 80, they pay 80, you pay 20, right? The second number is how much Bob pays. So Bob pays 30%. Okay? So Bob is going to have to pay the whole $1,000 for his deductible. That leaves $13,000 that he's going to have to pay a part of. And so we would take $13,000 and multiply it by the 30% that Bob has to pay, which is a 0.3. And so somebody tell me what this is here. Okay, I think that's the second part. Yeah, so we'll have 1,000 plus this part right here is going to be 3,900, and that's if you do it like in pieces, you'll get the 3,900, but then you have to add the 1,000 to it. So yes, yeah, that. And if you go straight to the answer, that's fine. That's good. So 4,900 for a knee surgery is how much Bob would pay with insurance. Oh, no, it's not. I didn't make it. I had this before, but I don't know how realistic this is. Riley's parents probably know how realistic it is, since they just paid or getting ready to pay for a knee surgery. I don't know if the bills have came through yet, but because I have not had knee surgery, but this is how insurance works. Now, insurance can vary wildly, so your insurance may be way different than somebody else's insurance. Well, also, like, just what company you're using, what your employer offers. Some policies will have really high deductibles, like $10,000 deductibles, so you got to pay a lot out of pocket before they cover. Some will have low deductibles, but then you'll have to pay more for your monthly rate. Insurance is a headache and so annoying. Yes, car insurance definitely works like that. And if you're already an experienced driver, it will be bad.
I have a funny story about like the insurance.
You're going to save it. We got to. Okay. All right. Now, this one I do know about its realisticness. Cause these are the numbers rounded off to even numbers, of course. So we didn't have. Now, the state health plan did not. We don't have this anymore. They changed it to where we don't have this, but we had this plan where you had a $1,500 deductible, and but you had like the savings health savings thing where they gave you like $600 a year, and if you didn't use that $600, like the next year they'd give you another $600, and you have $1,200, and then next year and so on. So when Miss Hyatt had a baby, Henry, the hospital charged $16,000. But I got an insurance discount of $7,000 because they'll charge a certain amount, then insurance will negotiate it down. So my bill was $9,000. Right? Because they charged $16,000. Insurance negotiated it down $7,000. So my bill was for $9,000 before insurance started paying, right? So I have $1,500 is my deductible, so I'm gonna have to pay $1,500. And then this insurance was $85.15. So I only had to pay 15% of what is left. So how much do I have left that I've got to pay? $9,000 minus that $1,500 is going to be $7,500. So I got $7,500 times 0.15 because I had to pay 15% of that. And so this is going to give me this is, are you guys getting $2,625? Did I do that right? Okay. $7,500 times 0.15 should be $1,125, and then you're adding the $1,500. Yeah. Okay, so $2,625. Now, I did have $600 in my health savings plan. So minus the $600 that was in my health savings plan, so $2,025. This unfortunately is only the hospital bill, not the bill that you got to pay to the doctor's office and to the pediatrician. Even though it's at the hospital, the pediatrician sends a different bill from the hospital. You'd think that'd be included. Yeah. Yeah. So, what for me, state health plan has a low out-of-pocket maximum. It's like $4,000. So after you've paid $4,000 out of pocket, it covers everything. And I had to pay like the $4,000, and then it paid everything after that. And I did not have a C-section with Henry. I did have a C-section with Hunter, but I did not with Henry. So this is not surgery. Yeah, that's major surgery too. It's major. So anyway, it's not cheap. Even though everybody has different insurances, so some insurances pay better and it's cheaper.
Is there any way to
I often make the argument that it is ridiculous that a hospital is charging $16,000 for something that hippies do in their bathtub. But you could, yeah. I mean, some people do have their babies at home. I mean, you go back long enough ago, everybody had their baby at home. It can be done.
I don't have to worry. I don't have to worry about this. My aunt said that is.
You're right.
That is targeting hippies because it's not just hippies that have
I would like to make the argument that if you have your baby at home, that you got to have a little bit of hippie in you.
Well,
A little
I
bit.
wouldn't want to pay $16,000.
You're right. You're right.
Listen, I don't care. You know, if it's just
Why is this?
I don't care about it. You know, a couple of $16,000. You can buy a home with it.
Yeah.
Leave it up to my wife. With all the money you spend, like
Yeah. Okay. All right. Let's do a few more. Okay. Before we've got to go. All right. To find a percentage. Okay. You're going to take the part divided by the whole, and then I should put right here, then convert to percent, because that's the part divided by the whole is going to give you the decimal. You got to change it to a percent. So, this is a problem that I got from my husband. His name is Todd. Because whenever this has been a while back, but whenever he worked, he had some guys working for him, and he needed to know what percent of the job sites had been looked at, because they've got like a certain number of job sites that they have to go see, and he has to inspect them. So he came home and he was like annoyed because the guys that worked for him didn't know how to find that percent. Like, he wanted to know what percent of jobs had been looked at, and he didn't. But they couldn't figure it out, so he was a little bit annoyed by that. So last month, Todd inspected 29 out of 32 job sites. What percent of his job sites did he inspect? So part over whole. What part did he inspect? 29. What was the whole number of job sites? 32. So we're going to get 0.90625, but that is the decimal. What do we have to do to change it to a percent? Move it to the right twice, so we get 90.625%. All right, so about 91. It depends on how precise you want to be. You can leave it like it is, or a lot of times I think I usually ask you round to the nearest tenth of a percent, so you would keep it like 90.6 there, or just keep the whole number fine. Yeah. All right. So in a recent thunderstorm, 2,750 of the 4,106 residents in Elkin lost power. What percentage of the population did not lose power? Okay, so this one's got a little bit of a twist. What's the twist? Not lose power. But what did it tell you? The ones that did lose power, right? So what have we got to do different here? We're not going to add them. Does it give us the total number of residents? That's the 4,106. Okay? All right. So what did you do? Okay. Okay. So what you did is you got 0.66975 and so on. You move that decimal two places. You got 66.975%. but these are the ones that lost power,
Yeah, I like it.
right? And so something like losing power or not losing power is a yes or no question, right? Yeah, so, well, because right here, all of these people either did lose power or did not lose power. There's not like a middle ground where they sort of lost power, right? So it's one way or the other. So you would have to, so this would have to add up to 100%. So you could just do 100% minus the 66.975%, and that would give you, what'd you get, Caitlin?
33, well, I did all the numbers, 33.024841.
I'm going to round that to a 5 right there. Now, is that the only way to do the problem? Okay. What else could you do instead? How else could you do this problem? Yes.
So, as I see it, you have 66, that's why 135.
Uh-huh.
If you just, wait a second. Otherwise, it would just minus that.
Okay. We could have worked with the numbers at the beginning, right? So if I got 4,106 people and only 2,750 lose power, how do I figure out the number that did not lose power? So 4,106 minus 2,750 would give us 1,356, and then we could divide that by 4106, and that gives us 0.330248, which, when you move the decimal 2 places, gives you the same answer right here. So, 2 ways to do the same problem. There's not really one that's necessarily easier than the other. Yeah, either one is fine on that one. Okay? All right, questions?
I put myself out there to see if I got it wrong.
Yeah, that good logic there. All right.
She told me so.